What's up, mathematicians? It's your boy Kennedy. Before we get started, I need you to hit that like and subscribe button. If you don't do that in the next 30 seconds, you'll have bad luck the rest of your life. I don't know. My kid watches YouTube videos, and that's how they always start them. So maybe that's how I need to start my YouTube videos. More people will be into my math classes. I only got 132 followers. What's that about? What's that about? I'm doing things that are way harder than playing Fortnite. I'll tell you that much. Today, what we're going to do, we're going to do lesson 2. So this is unit 5, lesson 2. We're going to multiply and divide some rational expressions. Yesterday, you learned all about these beautiful things, rational expressions. Basically, it just means fractions with letters. And then you learned something called NPVs. You did some factoring. It was really fun. You probably already liked and subscribed, so don't even worry about having to resubscribe because yesterday was so much fun. I know you probably hit me up, so that's pretty sweet. Before we get into rational expressions, let's multiply and divide just numbers. So multiplying and dividing is actually easy, which is kind of nice. So when you multiply fractions, all you have to do is multiply straight across the top and then multiply straight across the bottom. Like, it's really that easy, which is kind of nice. So on the top, you'd go 12 times 5 would be 60. And then on the bottom, you go 10 times 4, that become 40. Like, boom, that easy. You could then definitely reduce that fraction, right? Just like we were doing yesterday. You would notice that both of these numbers could divide by 20, and you'd end up getting 3 over 4. Sorry, 3 over 2. No wonder nobody subscribes. That's it. So multiplying fractions isn't going to be terrible. Dividing fractions, we're going to have to do a little bit of work. So I had a grade 6 teacher. I think it was my grade 6 teacher. She was my grade 6 student teacher. And you know how that goes sometimes. So this lady and she taught me math. Man, we did not get along. It was grade 7, not 6. We did not get along. She hated me. I don't hate anybody, but we didn't get along nicely. She taught me one thing that whole year, and that one thing has stuck with me my entire life. Literally, this woman taught me one thing, and it's never left my mind. And it's how to do fractions divided by fractions. So when you have this situation and you have a fraction divided by a fraction, she taught me this crazy thing called kiss and flip. So you take the first fraction, you leave it. Stays the exact same. Then you're going to kiss it, which means you're going to turn that division into a multiplication. It's called a kiss because it's an X, as in like XOXO Gossip Girl, right? Like hugs and kisses. So they change that division symbol to a multiplication symbol, and then you flip the second fraction. Like that. It's called a kiss and flip. It's genius. So this woman taught me this kiss and flip. I've been using it ever since I was like, I don't know, 9 years old, 10 years old, whatever grade you are, however old you are in grade 7, you're 12 years old. I was 12 years old. It still sticks with me. And the reason it's such a brilliant trick is because now you have multiplication, and we know multiplication's easy. Right across the top, negative 3 times 20 is negative 60. Across the bottom, 5 times 3 is 15. Boom, kiss and flip. How easy is that? That definitely reduces 60 can divide by 15. It's negative 4. Boom. Looking at this guy right here, we're going to do the same thing. Kiss it and flip it. So we're going to have the negative 1 over 6 stays the same. We're going to kiss that middle. Boom. It's now an X. Second fraction, we flip it. It's now 24 over negative 8. Multiply across the top, that's negative 24. Multiply across the bottom, that's negative 48. Both those things can divide by negative 24 to become 1 over 2. Bam! That's multiplying and dividing fractions. Now we're going to do the same thing, but with letters. So it's going to be like obviously a little harder because there's letters, but the steps are going to be pretty much the same, which is kind of nice. Before we get into it, though, we did learn about non-permissible values yesterday. So I usually don't call them non-permissible values because I don't know if you've noticed, but I'm a very lazy human. I call them NPVs. Right, let's just simplify it a little bit. I don't know how to spell permissible. That's the actual reason I call them NPVs. I'm not smart enough. So anyways, these NPVs, these are values that cause you to divide by 0, right? So for instance, if you looked at this first fraction right here, if x equaled 8, I would have 8 minus 8, which is 0, and then I would be dividing by 0, which is not allowed, right? You can't divide things by 0. So what we have to do is we have to define this. So we define this question by saying x cannot equal 8. It's called an NPV. Cool. And we learned yesterday that NPVs are on the bottom of fractions, right? It makes sense. That's where you divide things, right? So x cannot equal 8 because of that. And over here, we have another fraction. So if x was -3, it wouldn't work, because if that was -3, -3 plus 3 is 0. That's no good. But now we have a little bit more of an issue. So if you look, there's another division symbol right here now. And what that means is that this fraction as a whole can't equal 0. Otherwise, you'd be dividing by 0. So that means the top of my second fraction also cannot equal 0. That means I cannot have x equal +4. My NPVs would be 8, -3, and 4. You'll probably have to do that for like every question, right? It's just a good habit to get into. It's called stating your NPVs. And it'll definitely become important in about 3 lessons. All right, let's get into it. We're going to multiply some fractions here. Let's start with this one. So there's 3 steps to every question. The first step to every single question, no matter what we're doing, is factor, right? You can't factor this thing, but it's definitely still the first step you look at. The second step is stating your NPVs. NPVs are what cause you to divide by 0. Nothing is going to make this 10 equal 0. 10 is always going to equal 10. If I look at this 2c, though, I could make that equal 0 by making c 0, because c 0 times 2 would be 0. That means c cannot equal 0. That's my NPV. Once you've done those things, now you can get into simplifying this. To simplify fractions, here's my step. The first step I want to do is I want to turn it into one fraction. And once I have it into one fraction, then I can simplify that single fraction like I did yesterday. So to turn this into one fraction, I multiply across the top. C squared times 5 times d would just be 5c squared d. Divided by, I multiply across the bottom. 10 times 2 times c would be 20c. Once I have one fraction, then I can go and simplify that one fraction. My 5 and my 20, both things can divide by 5, leaving me with a 1 on the top and a 4 on the bottom. I look at my c's. I have c squared divided by c. I like to think of it as a little battle. So c squared means I have 2 c's on the top. They battle 1 c on the bottom. The top would definitely win, and they would have 1 left over. So it would be 1 c on the top. And then this lonely little d right here is still there. Now, typically, we don't write our answers with that invisible 1. So instead, I would say it's c d divided by 4 is my solution. If you did write the 1, hey, that's fine. Life happens. All right, this guy right here. We're going to do the same steps. First step is factor. That thing's already factored. The second step is stating my non-permissible values. Those are things that cause me to divide by 0. If I'm looking at this, things that cause me to divide by 0 would be right here. X cannot equal 1. If 1 was in there, 1 minus 1 is 0. That makes the whole thing 0. So x cannot equal 1. My second NPV comes from right here. That would be x cannot equal 0, because 2 times 0 is 0, and then that whole thing would be 0. So my NPVs are 1 and 0. Cool. So first step was factor. Second step was do my NPVs. Now I'm on to actually simplifying. The first job I need is to write it as a singular fraction. To write this thing as a singular fraction, I'm going to multiply across the top. But when I multiply across the top, I don't want you actually expanding everything. That's going to be a crazy amount of work. All I want you to do is multiply the monomials together. So my monomials would be 4x and 5. So multiply your monomials together to become 20x. And then just go ahead and write the binomials out like you normally would. X plus 3, x minus 1. There's no need to actually multiply those things together, and you'll see why in a minute. In the denominator, I'm going to do the same thing. Monomials can multiply together. So 3 times 2 would be 6x. And then my x minus 1 will stay there. Awesome. I've now written it as a singular fraction. Now I want to simplify that fraction. And the reason we didn't want to expand and actually multiply those binomials together is because the only way I can simplify things is if I'm factored out, because I have to cancel entire binomials with entire matching binomials like that. Where if I had multiplied together, I wouldn't have those x minus 1s to cancel anymore. Other things that cancel, this x and this x cancel. Also, this 20 and this 6 can both divide by 2. This leaves me with 10 times x plus 3 on the top divided by 3. And that is my final answer. One of the hardest things to do in this unit is to know when to stop. So something people do here is they go 3, 3, and they cancel those out. That does not work because that 3 on the top is attached to this positive x. This is a binomial. It's a package. It's stuck together. The only way you could cancel any part of it out is if you canceled the whole thing out with another x plus 3. It's stuck like that. All right, if we were in class right now, this would be the point where I would stop the video and I would give you about 5-6 minutes to try both of these questions on your own. You need to do that right now. And I know most of you guys are just like, oh, yeah, and you're hitting play. Don't do that. Don't ignore this opportunity to practice. So pause the video, try both questions, then unpause the video and watch how I do it and see if you got it right or wrong. That's how you know if you understood it or not. So go ahead, pause, do the thing, come back. Cool. At least maybe a couple of you actually pause. The rest of you are just ignoring me. It hurts my feelings, but whatever. It's just me, right? I don't need feelings. Merry Christmas. Simplifying this. If I want to simplify this thing, the first thing I do is factor. I can't factor it. Second thing I do is state my NPVs. A cannot equal 0 in this question. If A equaled 0, that whole thing would be 0, and then I'd be dividing by 0, which is no good. Cool. Now we get into the simplifying. To simplify, you multiply the top. That's 6ab squared divided by, multiply the bottom. 9 times 5 is 45, a squared. Once you've done that, you then can simplify. 6 and 45 both divide by 3 to become 2 on the top and 15 on the bottom. Then my A's, I have 1A on the top, 2 A's on the bottom. That means I'm going to be left with 1A and it's going to be on the bottom. And my B squared is just sitting up top still. My answer is 2B squared, 15A. Cool. This one. First step is factor. It's already factored for you. Second step is state your NPVs. My NPVs are things that cause me to divide by 0. X cannot equal 0. It also cannot equal negative 2. If x equaled 0 there or there, the whole thing would be multiplying by 0. And if x equaled negative 2 right there, that'd be no good. Cool. Now I'm on to my simplify step. When I simplify, I want to write it as one fraction and then simplify it. So I want to go monomials with monomials to become 10x squared, x plus 2, x minus 4. In the denominator, same thing, monomials with monomials. So 3x times 8x is 24x squared, and then x plus 2. Once you've written things as a single fraction, then you can start to reduce that fraction. So I look at my monomials first. My 10 and my 24 can both divide by 2 to become 5 and 12. My x squareds in the monomials can cancel with each other. My x plus 2's, the entire binomials can cancel with each other. And that x minus 4 on the top cannot cancel with any x minus 4's on the bottom, so it stays the way it is. My answer should have been 5, x minus 4 divided by 12. Wicked. That's multiplying fractions. Hopefully you're crushing it. Let's look at these bad boys. Look, we're getting there. Look at how it's about to get crazy. Look at these questions. The mayhem's coming, don't you worry. We're going to divide. So I'll do 2 with you, and then you'll do 2 on your own. First step, is state your NPV or factor. We can't factor this one. So then we state our NPVs. If I look at this denominator, none of this denominator can divide by 0. It's fine. There's no way negative 2 is going to become 0. Look at this denominator. It's just 6. There's no way 6 is going to become 0. So it's fine. But if I look here, because I am dividing by the entire fraction to the right, this cannot equal 0. That means my NPV is n cannot equal 0. Cool. Now, I look at this question, I realize it's division of fractions. So I'm going to do my little grade 7 teacher's trick. I'm going to kiss and flip. So that means it's 5n to the power of 4 divided by negative 2 turns to a multiplication, and the 6 is on the top. And instead of 5n squared, I'm going to bring that squared in to become 25n squared. The reason I'm doing that is I'm going to have to multiply my bottoms, so I need to see what it actually is. I can't be multiplying by that 5n squared. Now that it's multiplication, I'm just going to multiply across the top, multiply across the bottom. So this will become 30n to the 4 on top. The denominator will become negative 50n squared. I then can start simplifying. The coefficients all divide by 10. I'm also going to float that negative to the top to become negative 3 divided by 5. I'm then going to look at my variables in my monomials. I have n to the power 4 divided by n squared. 4 minus 2 is 2. That's n to the power 2. And that is my answer. All right, let's try another one. So I look at this guy. First thing I want to do, factor. It's already factored for me. Second thing I want to do, NPVs. I can't have 0 right there. Also can't have 0 there. I can't have positive 2 there. And I can't have negative 1 right there. So my NPVs would be 0, 2, negative 1. Gorgeous. Now let's get to the question. I need to simplify. I notice it's a division of fractions. I don't like division of fractions, so I need to do that trick that Miss, I don't know what her name is, taught me in grade 7. We're going to kiss it, and we're going to flip it. You know what the worst part about that teacher? Let's just talk here while I write this down. I'm kissing and flipping here. The worst part about that teacher, like real talk, she hated me. She almost failed me grade 7 math. You believe that? I was the top kid in the class, and then I almost failed because she taught me for 2 months. And then my other teacher took over, and he put me back to like 95%. Anyways, talk about this woman. At the end of the year, she wrote me the nicest card, being like, "Oh yeah, you're such a great student." Like, don't lie to me. Tell me that you love me and that it was such a great year teaching me. Can't stand that nonsense. All right, anyway, back to this. So you'll notice I kissed it and I flipped it. Thanks, lady, that I don't remember your name. Change that to multiply. Flip this fraction. Gorgeous. Now we can write this as a singular fraction. On the top, I have a 2 and an x to become 2x. The x plus 1, the x minus 2, I don't want to actually simplify or multiply. I just want to write them out. On the bottom, monomials go together. 3 times 4 is 12, x. And then the x minus 1 is still sitting there. Cool. Simplify this. So now it's one fraction. We can look at these monomials. The x's will cancel. 2 divided by 12 will become 1 on the top and 6 on the bottom. You then look and our binomial. Oh, I almost screwed that up. I got chatting and then I almost screwed everything up. This should be a plus 1 right here. Oh, plus 1. You imagine that? Okay, if I look at these, I have an x plus 1 can cancel with this entire x plus 1. The x minus 2 stays as x minus 2. So my answer is x minus 2 divided by 6. Again, we don't normally write that 1 out front, so you should just get used to looking at it like that. I like to put brackets around the binomials so that I remember not to cancel out that 2 and that 6, because that 2 is part of a binomial, right? It's stuck with it. All right, people. 2 questions right here. Same idea. Hit pause. Go practice them on your own. Then come back and check out how you did. Looking at this guy. I'm going to rip through these guys pretty quick here. My NPVs would be n cannot equal 0 because of this spot right here. Cool. Now, we're kissing and we're flipping. So the 7n cubed divided by 4, don't touch it. Change it to multiplication, flip the second fraction. Again, that squared is going to come in to become 49n squared. Gorgeous. Once I've turned into multiplication, I'm going to multiply across the top. 7 times 12 is negative 84, n to the power of 3. In the denominator, 4 times 49 is going to be 196 n squared. Oh man, if that's right, I think it's right. Once you've written everything as one fraction, you can use yesterday's lesson and just simplify it. If you look at these two numbers, we have 84 and 196. Both of them can divide by 28, I think. They're both going to divide by 28. I'm pretty confident in that. If you divide both by 28, you're going to get negative 3 on the top. And you divide the other one by 28, you're going to get 7. Pretty confident in that. I then can also cancel out these n's. I have n to the power of 3 divided by n squared. That means I have one more n on the top. I should have negative 3n divided by 7 as my answer. Hopefully you crush that. That's actually harder than the other one, I think, even though it's monomials. All right, let's look over here. So, first thing you did, you factored. You didn't have to factor because it was already factored for you. Second thing you did, stated your NPVs. NPVs were x cannot equal 0, negative 5, and 3. Hopefully you got that right. Then you kissed and you flipped. So you would have 5, x minus 3. I think her name was Miss Anderson. 2x times 3x, x plus 5, divided by 10, x minus 3. Cool. Across the top, I can now multiply, right? That's the whole purpose of this kissing and flipping. So 5 times 3x is 15x. The x minus 3 and the x plus 5, I don't want to expand on them. I want to leave them like that. In the denominator, 2 times 10 is 20x, and then x minus 3. Now that it's a singular fraction, I can start to simplify things. The 15 and the 20 both divide by 5 to become 3 over 4. The x's will cancel out in the monomials. The x minus 3's will cancel out. And the x plus 5 will be left over on the top. Again, I don't actually have to multiply it out. I just have to write it. Awesome. Okay, let's get into some harder stuff here. We're going to do 2 together, and then we'll leave you to do 2 on your own, and we're not going to do this last one. So, let's start with this guy. Now we're getting into it. Now we're getting like the big questions, the test questions here, folks. You need to now remember all your steps. So for any question where we're simplifying, the very first thing you need to do is you need to factor. And there's going to be a lot of factoring. My suggestion to you is like have a little side scrap piece of paper, especially when it comes to test time. Like you're going to sit there with your side piece of paper and you are going to factor on it all day long. So you need to have that scrap paper. This top one will factor to be x plus 4, x plus 1. The second one below has a GCF of 2. So you need to take the GCF out. Then you need to factor it with diamond method to get x minus 2, x minus 2. Multiply by. 4x minus 8 has a GCF of 4, leaving you with x minus 2. The binomial underneath it is a difference of squares. I can square root it to become x minus 1, x plus 1. So right there, like, if you can't factor, you're hooped. Like, you're in so much trouble. And in yesterday's video, I would have said that a bunch of times. I would have been like, if you can't factor, you're in trouble. If you still are at the point where you just got lost while I was factoring, you need to reach out and be like, oh my gosh, give me factoring practice, please, because I need to get better. Because you literally will be doing stuff like that for the first step of every question for the next 2 weeks. So you need to be good at factoring. All right. Now, after I factor, I state my NPVs. I always like to write my NPVs at the top of my question so I don't lose them. Remember, NPVs are things that cause you to divide by 0. So in this case, x cannot equal positive 2, positive 1, or negative 1. Those are my NPVs. Sometimes people add x cannot equal 0. They're just like, oh yeah, that's just one of the things. X is allowed to equal 0 here, right? At no point would that cause you to divide by 0 if x equaled 0. So just be careful of that, right? Don't just add NPVs because you want to. Your next goal is then to write this as a singular fraction. Combine it to become 1. On the top, you want to multiply monomials with monomials. There's only one monomial here. We're just going to move it to the front. And then everything else stays the same. It just becomes x plus 4, x plus 1, x minus 2. In the denominator, we're going to do the same thing. So monomials go out front. There's only one monomial here. It's 2. And then everything else stays the same. X minus 2, x minus 2, x minus 1, x plus 1. Once you're a single fraction like this, now we can just start simplifying things, right? So I look at my numbers, 4 divided by 2 turns into 2. I then have an x plus 4 on the top. It can't cancel with anything, so it stays as x plus 4. I have an x plus 1 on the top. Boom, that thing cancels with this x plus 1 over here. I then have an x minus 2 on the top. Boom, that thing cancels with this x minus 2 in the bottom over there. Divide by. All I got left is an x minus 2 and an x plus or x minus 1. That is now fully simplified. I know it's fully simplified because it's one fraction. I can't factor it, and there aren't any packages that cancel out. So I know I'm done. All right, last one. This guy. We're going to factor it. Again, the factoring is hard on some of these. So this first one, I can factor 4x minus 10. People always forget to GCF, but that thing GCFs. So a 2 has to come out, and then it's 2x minus 5. Below it can't factor, so I leave it as x plus 3. Then I get to this terribleness. Look at that thing. That's brutal. Now, if I'm you, I need to write that out on a side piece of paper, right? Like, I can't do that one in my head, so I don't expect you to be able to do it in your head. First thing I'm going to do is I'm going to GCF out of 3. When I GCF out of 3, I'm going to be left with 4x squared minus 20x plus 25. Then I'm going to do a little diamond method on that thing. It's going to be things that multiply to be 100, add to be negative 20. It's negative 10 and negative 10. That means this turns into 4x minus 10, 4x minus 10. And I have to divide one of those by 4. I can't divide either one by 4, so I have to divide both of them by 2 to multiply to be 4. Give me 2x minus 5, 2x minus 5. And like, instead of doing that right here in the middle of my paper and making my work all messy, right, I just do that on the side somewhere so it doesn't make my question look bad. The next little denominator, I'm going to do the same thing, right? I'm going to GCF out of 2, but after I GCF out of 2, I'm left with x squared minus 9. That's a difference of squares. So now I have x minus 3, x plus 3. So that's a lot of factoring. And again, if you struggle with factoring, this question now just gets that much harder for you, where maybe the guy beside you can factor in his sleep. And now he gets to worry about the other stuff in this question while you're worrying about the easy stuff in this question. So if the factoring's hard, ask for practice, ask for help, like put in the work, make your life easier when it gets to these bigger questions. Perfect. I've only done step 1. I've only factored here. Step 2 is state your NPVs. My NPVs are x cannot equal negative 3 because of that one. Positive 3 because of that one. This one's also negative 3, not a big deal. And then we get these guys, the 2x minus 5. So if I wanted to see what would make that equal 0, well, 5 minus 5 would equal 0. So I put 5 on the top. And then I have to cancel out that 2 somehow, so I would also divide by 2. The 5 would subtract by 5 to be 0, and the 2 divided by 2 would cancel out. So my NPVs are -3, +3, and 5 over 2. Awesome. Now let's kiss and flip this guy. So we have 2x minus 5, x plus 3. I have to kiss and flip, so it becomes a multiplication. X minus 3, x plus 3. In the denominator, I have 3, 2x minus 5, 2x minus 5, like that. I then can write as a single fraction. The monomials are going to go together to become 4, and then write everything else out. 2x minus 5, x minus 3, x plus 3. In the denominator, the monomial goes out front, and then I write all the binomials out. X plus 3, 2x minus 5, 2x minus 5. And now I've got a singular fraction because I've multiplied properly. I can now start canceling things out. The 4 over 3 isn't going to cancel out. One of the 2x minus 5s will cancel with one of the 2x minus 5s. The x plus 3 will cancel with the x plus 3. And I'm left with an x minus 3 on the top and a 2x minus 5 on the bottom. That is complete because I cannot factor it anymore and I cannot cancel out any more packages. Awesome. That is as hard as it gets. That'll be a hard question. So when it comes to multiplying or dividing, that second one, that's probably like the upper echelon of what you'll see. All right. There's 2 questions here. I want you to pause the video, try them your best, come back, see how you do. We're not going to do these next couple questions. We're just going to leave them. I only ever do them if we have extra time. COVID world, I don't think we got extra time, right? So let's just keep it to what we need. Pause, practice these, come back, watch the video. If it doesn't work, pop into class, ask me for some help. Let's figure stuff out, right? We're in this together. Okay. Hopefully you did that. If you come to this one, when you factored, you should have had x plus 4, x plus 5. In the denominator, you should have taken a GCF of 2 out. Then you would have had x plus 4, x minus 1. He says with 0 confidence. Let's see what that'd be. Yeah, that would work. Times x squared minus 1 is a difference of squares. It's x minus 1, x plus 1. Divided by, take the 3 out. I'm left with x plus 5. Cool. My NPVs. You should have stated that for this question, right? Get in the habit every single question. The NPVs are -4, +1, and -5. Awesome. I now want to rewrite this by multiplying together. On the top, I have no monomials, so I'm literally just writing them all out multiplied together like this. In the denominator, I do have 2 monomials, right? I have a 3 and a 2, so they multiply together to be 6. And then I have x plus 4, x minus 1, x plus 5. The reason we want to write things as one fraction is because then we can do our trick of canceling things out. So this x plus 4 cancels with this x plus 4. This x plus 5 cancels with this x plus 5. This x minus 1 cancels with this x minus 1. And this massive equation simplifies to be a nice, clean x plus 1 divided by 6. Gorgeous. Hopefully you got it. If you didn't, my guess is the factoring, right? That's probably where you went wrong, probably where you spent a lot of time. So get good at that factoring. All right, over here. First step, we're going to factor. I have x minus 2 on the top. In the denominator, I take out a 3. I'm left with x minus 7. Division turns into multiplication. Oh, let's not do that yet. Let's leave it as divide. Let's not try to do too many things at once here, Mr. Kennedy. On the top, I would take a GCF of 3. That would have left me with x squared minus 4. X squared minus 4 can be square rooted, which would have given me x minus 2, x plus 2. Like that. In the denominator, I take a GCF of 3. I then can diamond method the remainder. I would be looking for things that multiplied to be 21 and add to be 4, negative 4. So I would have x minus 7, x plus 3. I think that works. Negative 4 times 3. Yeah, that does work. Hey, look at that. That's just the first step. That's just factoring, right? And that's hard factoring. I then am going to write my NPVs. I like to always put them near the top. X cannot equal positive 7. It cannot equal negative 3. It also cannot equal positive or negative 2. Cool. That's a 3. There we go. Now I can focus on my simplifying. So I'm going to kiss it and flip it to make it multiplication, because multiplication is easy. In the denominator, I would have 3x minus 2x plus 2. Cool. Then I want to write things as a single fraction. So the 3 goes out front. I then have x minus 2, x minus 7, x plus 3. In the denominator, I've got 9, and then x minus 7, x minus 2, x plus 2. The 3 and the 9 can divide, right? Both of them divide by 3, leaving me with an invisible 1 on the top and a 3 on the bottom. I then have an x minus 2 cancel with an x minus 2. I have an x minus 7 that cancels with an x minus 7. And I'm left with an x plus 3 on top and an x plus 2 on the bottom. My answer is x plus 3 divided by 3 times x plus 2. Wicked. That is multiplying and dividing. Next class, we're going to move on to adding and subtracting. The adding and subtracting is much harder. Just for the record, there's another step, and it does get harder. So you want to probably get good at the easy stuff, which is multiplying and dividing. That's what we did today. Cool. Take care. Before you sign off, make sure you remember you like, and you subscribe. And I'll give one of my subscribers $10,000. Just want you to know that HJ Coding and Shook's Edge School Division do not support that claim and are not in any way affiliated with my lottery handing out to people who subscribe. Also, I'm not liable. Okay, bye.